This is a module about Istio. It's about Kubernetes. It's module 4. It's about fault injection. Ultimately, it's about preventing a poor user experience because of slow responding services. So it's about intentionally delaying traffic routing so that we could test the performance of our applications. Before diving into this module, Module 4, be aware that there are 3 previous modules. Module 1 is kind of an introduction, getting set up, installing Istio, installing the Bookinfo sample app. Number 2 module is about getting introduced to route rules and how to route traffic to specific pods. Module 3 talked about inspecting HTTP headers so that we could direct traffic to specific version numbers of the review service. So this video is really about testing the end-to-end failure recovery capability of the application as a whole. The problem we want to solve is really looking at misconfigured recovery policies. We're looking for incompatible or restrictive timeouts across service calls. At the end of the day, what we are really interested in is avoiding a poor user experience. So what we want to do is intentionally force a timeout. That's the point of today's session here, is to force a timeout. Therefore, testing the recovery capability of our application. So as we talked about Istio in combination with Envoy on Kubernetes, the point is to make applications more fault resilient. We will explore the following capabilities in this video and some of the subsequent videos coming up. One of those is supporting timeouts. So we'll set the timeout for 7 seconds to reach the rating service, and we'll see the web page timeout and provide the appropriate error message given the timeout. We can also enforce bounded retries with timeout budgets and jitters between retries. We'll also take a look at limiting the number of concurrent connections and requests to upstream services. Another capability of Istio and Envoy is to perform active or periodic health checks to each member of the load balancing pool. Finally, we'll talk about supporting fine-grained circuit breakers. Now, if you go to the Istio site, you will see the example here that will inject a 7-second delay between the reviews version 2 and ratings microservices only when the HTTP header says JSON. For all other users, they will not experience this necessarily slow performance. There will not be a fault injection for anyone other than user equals JSON in the HTTP header. So just to be crystal clear about this, by default, all users will go to reviews v1. And by default, all users will go to ratings v1 without delay. But the user equals JSON in the HTTP header will be treated differently. Those users will get routed to reviews v2. And when they get forwarded to the downstream ratings v1, there will be a fixed delay of 7 seconds. So this diagram really depicts what we expect to see at runtime when this thing is operational. So let's talk about the remaining steps. The first thing we want to do is remove any existing routes that might exist. We will then add in the new routes. Those are the routes that include the 7-second delay. And then we'll actually be implementing fault injection by doing so. From that point, we'll validate that the web app times out and that the web page provides the appropriate message as a result of that timeout. Okay, so we're ready to begin actual hands-on here. So let's go ahead and get a listing of all the route rules with the command you see there. We have a number of route rules we wish to delete. A little Python script I wrote to help out here. And what it does, it goes through and writes my delete route rule command here and makes it a little bit easier for us to get this done. I'm going to go ahead and delete all the existing route rules. Your system may not even have any, but we're deleting them. Those route rules are now gone. And now it's time to really add the ones we want that we've been discussing. And you'll notice over here we have a bunch of create commands that make that possible. Let's go ahead and take a look at those. I'm not going to review all the commands. You can see the route rules here below. You can go look them up. But the one I want to highlight is the last one, route rule ratings test delay. Notice here towards the bottom it says HTTP fault delay percentage 100% of the time. I want you to delay 7 seconds before the reviews can reach out to the rating service. So that's where the delay takes place. We'll take a closer look in the browser to verify this. The other thing to notice here is that in fact it only does this when the user equals JSON. So that kind of explains how this works. Let's go ahead and see it in action. So let's go ahead now, recreate those rules we just looked at. Should be pretty straightforward. These are the 3 YAML files that represent all of the rules as we discussed. That's now in place. Those have been added. Let's just verify real quick with a get route rules command. Sure enough, they're all in place. We're good to go. On to the next steps. We can see the ratings test delay is in place. Okay, let's really find out where the rubber meets the road. We'll do a kubectl get ingress to get the public IP address for the product page, 1364.65.34. We'll navigate to that public IP address and see a regular functioning application. It all looks good. We got the reviews. Things are working. Now as the next step, what we want to do is sign in as user equals Jason. And so you're going to notice at this point that we will in fact time out, because after all, if the header has user equals Jason, the HTTP header, we're going to get a timeout scenario. And you can see here 6 seconds represents a timeout. You can see the error message. Things did not work. So once again, if you go into the network performance pane of the web browser, you'll notice that product page did in fact take 6 seconds, which does align with the timeout we saw here in the route rules rating test delay YAML file. The fixed delay of 7 seconds caused this thing to time out and for us to see the error message. So once again, the reviews we're calling the ratings. There was a big delay between reviews and ratings. That caused the error message you see here in the red box. And that really does demonstrate how fault injection might be implemented here. Which does bring us to the end of this video, where we wanted to demonstrate how fault injection works. We gave some concrete examples, and it gives us the opportunity to improve our microservice application in the event there are timeouts. So this concludes Module 4. We basically gave some demos on fault injection, how to delay traffic so you can test your application resiliency. And as a final reminder, there are 3 modules before this one. These are kind of necessary to make sense of the one that we just demonstrated. So thanks for watching. See you next time.